Okay, we're going to go ahead and do Unit 3.4, adding, subtracting, and multiplying radical expressions. I've got it all worked out. I'm going to be using a red pen just to highlight because this unit, if you understand the previous three, this really doesn't become very difficult. Okay, so the key thing here is to understand the idea of like radicals. Okay, and to be a like radical, they have to have the same index, in other words, square root, cube root, fourth root, and the same radicand, that is the number underneath the radical. If they are exactly the same, then you can add or subtract them because they're like terms, right? Just like we know that 6x plus 5x, well, what is x? X is just some unknown value, but because we call them both X, we know that they're the same value. So we're free to add those up and say that's 11X. Well, likewise, if we have like radicals, so both are square roots, both have a radicand of 3, then we can just count them, right? Six square roots of 3 plus 5 square roots of 3 adds up to 11 square roots of 3. Okay, so just exactly the same thing as like terms. Here, the -8 square root of 14 and the -4 square root of 14, those are like radicals. Square root of 14 can't be simplified. And so I'll just go ahead and combine those coefficients. -8 minus 4 is -12. That's a 14, square root of 14. And then the 6 square root of 2, the 2 square root of 2 adds up to 8 square roots of 2. Okay, so very, very simple. Now, we'll complicate it a little bit in a minute. Let me go through this. The again, adding or subtracting, the big mistake that's often made is going to be right in here, where you often don't distribute this negative sign correctly right here. So if you have in parentheses preceded by the negative, remember, you're really going to distribute a -1, which is going to flip signs. So dropping the parentheses, I can just drop these parentheses because there's nothing in front and implied 1. So 2 square root of 2 plus 6, and then I distribute that -1. That'll give me -5 square root of 2. And -1 times a -6 is a +6. So this is often a sign mistake. And then as before, we combine like terms, we end up with a net -3 square roots of 2 and a +12. Here we have 4 that are exactly the same radicals. They're like radicals. And so we just simply can add up the coefficients. 6 minus 6 is 0. -2 minus 3 yields us -5 fourth roots of 13. Now, what happens if they're not like radicals? Well, if we can simplify the radical, we do that because we ultimately will likely have like radicals in these problems. So 125, if you use the the breaking them down into their prime factors using a factor tree. So 125 is 5 times 25, and then 25 is 5 times 5. Well, every time, since it's a square root that we get a pair, that number appears on the outside. So those two fives come out as a 5 in front. This one 5 that was left over that doesn't have another matching pair stays in. And now you can see we have like radicals. We have square roots of 5 in both cases. So we just add those up, 8 square root of 5. Same thing here, 45, we can break that down into a factor tree. We see we have 2 3s right there and a 5 left over. So the 2 3s come out as a single 3, which will multiply the -3 on the outside, giving us a -9 square root of 5 minus 2 square root of 5 yields us -11 square root of 5. Okay, so you can see if you can break down these radicals into a simplified form, we can often combine them together. So here's just another example. That can't be simplified right here, so that stays as is. 343, if you take a look, it's not even, so it's not divisible by 2. If you add those digits up, 3 plus 4 is 7 plus 3 is 10. 10 is not divisible by 3, so we know it's not divisible by 3. It's not divisible by 5 because it ends in a 3. I'm not checking any other even numbers because it won't work. So the next possibility is 7. And so if you get your calculator out, 343, if you divide it by 7, you get 7 times 49. And 49 breaks down to 7 times 7. So here's a pair of 7s. Since we're doing a square root, that can come out and we'll multiply the 4 in front, yielding a 28 square root of 7. 20, if you break it down, we have a pair of 2's. So a 2 will come out that yields the -6 when it multiplied the -3. And then here we have two like radicals, the 2 and the -6 square roots of 5, yielding a -4. And then this one has no place to combine. So there's the solution. Okay, again, same idea. This one just contains a mixture of variables and numbers. So 243, that is divisible by 3. If you add the digits up, they add up to 9. 9 is divisible by 3. So 3 times 81. 81 is 9, and then 9's break down into 4 threes. And so since we're looking for fourth root, I circled the 4 threes. So that brings a 3 out front, but it does leave 1 3 left on the inside right there. And then s to the sixth can be broken down. I didn't show it, but that can be s to the fourth times s squared. S to the fourth is a perfect fourth root, so out comes the s right there. And then the s squared stayed on the inside. And then over here, the only thing that we had to break down is really the s. That's s to the fourth, s squared. S to the fourth comes out as an s, so there's the 2s right there. And then the s squared stays on the inside. The 3 obviously couldn't break down. And now we have two like radicals, fourth roots of 3s squared. So we combine 3s plus 2s gives us 5s, 3s squared, fourth root. Okay, you can see some problems, a little bit of kind of perimeter. And so here, these problems ask for the exact perimeter and the approximate. Now remember, the most precise answer is leaving it in radical form. Okay, so perimeter, the formula for perimeter of a rectangle is 2 times the length plus 2 times the width. Okay, so let's break down the length, this 180. We break it down, you can see the factor tree. I'm not going to go through the whole factorization, but a 3 and a 2 comes out and multiplies to be 6, leaving me just a square root of 5. The width, when I break it down, those two 3's come out. It's a single 3. I still had a square root of 5 left. So there's my width. If I just plug into the formula 2 times the length, which is right there, 2 times the width, which is right there, gives me 12 square root of 5 plus 6 square root of 5, which adds up to 18 square root of 5. Again, that is the exact answer that I would put in because the most precise contains the radical. If I approximate and I get my calculator out and do 18 times the square root of 5, it's going to round to the nearest tenth to be 40.2. So that would be the approximate answer, rounded to the nearest tenth. Okay, when we multiply radical expressions, the only requirement really is that they have the same index, right? And if they do, we can multiply the radicands, the things underneath the radical, right? So here we go. They're both square roots. 5 and 10 by themselves don't simplify. So if I multiply 5 times 10, I get 50. I multiply the 5 and the -4, I get a -20. Well, 50 breaks down into 25 times 2. 25 is a perfect square. That comes out as a 5. 5 times -20 is -100. And I left the 2 under the radical. Okay, so this should be pretty familiar. Okay, same thing here. They're both fourth roots. So by themselves, I can't simplify them, but if I multiply 6b cubed times 8b cubed, I get 48b to the sixth. Remember, when we multiply exponents b cubed times b cubed, we add those exponents, giving us a b to the sixth. And then we do the same breakdown, right? 48, if you break it down, you're going to end up with 4 2s right here. So that means a 2 will come out and multiply that -3 out front, giving us the -6. B to the sixth breaks down into b to the fourth, which is a perfect fourth power with b squared left over. So that b will come out, but the b squared remained in, and as did the 3. So there would be the simplified answer. Okay, let's scroll down. Same thing here. Just go ahead and multiply. They're both cube roots, so I can multiply the radicands. When I do that, I get this. All 3 of those are perfect cubes, so I just simply take the cube root of all 3. Both are fourth indexes of 4, fourth roots. If I multiply 27 and 3, I get 81. X times x cubed is x to the fourth. 81, if you don't recognize it, is going to be a perfect fourth power if you break it down. So that comes out as a 3. X to the fourth, of course, is a perfect fourth power, comes out as x. Okay, this should not be unusual. If I had 3 and I wanted to multiply it by x plus 4, we understand that we can distribute, right? We just simply multiply through. So that's exactly what we're going to do right here, is we're going to go ahead and just distribute. So 7 square root of 7 times 5, 5 square root of 7, square root of 7 times the square root of 14 is the square root of 9. It becomes square root of 98. 98 breaks down. And so I will end up with a double 7, which can come out. The 2 does not have a match, so it stays in. These are not like radicals, so that's as far as I can take it. And again, I'm not going to necessarily explain all of this. You can see it, but I'm going to do 2 distributions. When I distribute the first, I get 12 square root of 147. When I break 147 down, I get a matching pair of 7s, which will multiply the 12, leaving the 3 inside. 98, I get a matching pair of 7s come out, multiplies the 4 to give me the 28. The 2 remains on the inside. Since these are not like radicals and I am adding, that's as simple as I can get it. Here we got another rectangle, but this time they want to know the area, right? So the formula for the area is simply length times width. I'll go ahead and multiply those. It may be easier to break these down first before you multiply, just because it'll be an easier numbers to work with. 125, we already know is 5 cubed and simplifies to 5 square root of 5. 45 is 9 times 5. The 9 comes out as a 3, so it simplifies to 3 square root of 5. And again, I'm assuming you know what I've done. This is from previous unit. And now it makes sense to multiply. Well, 5 times 3 is 15. 5 times 5 is 25, which is a perfect square. So 25, take the square root of, comes out as a 5. 15 times 5 is 75. So the answer would be 75 square meters. Okay, last is multiplying a binomial times a binomial. We can use that FOIL. It stands for first, outside, inside, last. So maybe it's easy to do it like I do it here. So first will be these two. So if I multiply those 2 radicals, I get 4 times 3 is 12, and then 11 times 11 is 11 squared. So 11 squared, take the square root, comes out as just an 11. So 12 times 11 is equal to 132. Outside, multiply the outsides. 4 times 2 is 8, so that'll be 8 square root of 11. Inside, just multiply those, 15 square root of 11. And then last would be 10. So when I add up all of the results of the FOIL, here is the expression. I can combine the numbers to be 142. These are like radicals here, so I just add their coefficients, and that's the simplified answer. Okay, last one. Again, I'm employing FOIL first. 5 times 5 is 25. Outside, 5 times 7 is 35, square root of 3. Inside, minus, again, watch the negative sign in front. That'll be a negative 35 square roots of 3. And then last will be negative 49. And 3 times 3 is 3 squared. Well, 3 squared, if I take the square root, just comes out as 3. Negative 49 times 3 is negative 147. If I add them all up, I can see that these two middle terms just cancel each other out because plus 35 minus 35 square roots of 3 add up to 0. 25 minus 147 adds up to negative 122. Okay, very good.